Before we begin, I have a question for you. Have you ever looked at something and said, well, somebody else has done it, why should I bother? I want you to think about this as we go forward. Why wouldn't you make your own version of something? Who knows, you might actually contribute something to the world.
This is what I call a ratchet joint. There are multiple names for this, but as far as I can tell, there is no industry standard. Just mechanisms that resemble this concept over and over. It is composed of two opposing pieces with teeth on them like a gear. The teeth on these gears mesh to hold the joint in place. The spring keeps these teeth engaged until a certain amount of torque causes it to rotate. Torque is another name for what physics call a moment, which is force times distance. I have tried to recreate this type of joint in many iterations. It has been used in commercial action figures and toys for a long time. Yes, I still have Jetfire. It is great for holding limbs in position for posable art, but it can also be used for numerous applications like holding my iPhone camera in place for YouTube videos. Adam Savage has posted his own version of a posable phone boom. His is made using loc-line, which is rather ingenious. I thought about duplicating this, but my creator brain says, why not make your own version? Live a little. I've gone through several iterations of this design alone. The assembly is composed of locking discs that are modular and can be swapped out for new designs. This way I never have to reprint the whole piece. I can just reprint this disc. The current design is with a set of convex and concave interlocking hemispheres. This is inspired by what's called a torque limiter. These use a series of ball bearings locked in place by bell washer springs to provide a set amount of torque for a ratchet.
So something got me thinking. Adam's version with the loc-line has a lot of degrees of freedom since it has hemispherical little joints as they move up the whole spline. I'm only going to have linear movement on here unless I turn it and move it wherever I want to. I'm not going to have much. So I need more degrees of freedom. So I designed a ball joint that will fit somewhere at the bottom here to help give it some articulation. I also added some even longer pieces that'll help make this reach considerably further. I've already had problems with this version not having enough tension due to the torque applied over the length of the device. And you can tell here, I've bottomed out the springs. I've bottomed these springs out. I've got these tensioner knobs tightened as tight as I can get it. So much so that I had 3D printed knobs, the threads just completely stripped out. So I've also ordered some aluminum knobs from McMaster-Carr as well. So we gotta make some things more rigid. 3D printing doesn't solve everything. I also have some creative ways I've blended in hex nuts or other pieces that need threads in the other design for the spherical joint. And I hope to share how I fit them in there and talk about fits and how to retain things in the plastic. Hopefully it'll work, we'll see. All of this effort aside, I've made so many of these discs to retain these pieces in position. I have a thought in the back of my head that's kind of daunting, and it's anything that can happen in prototyping work. You might pursue an idea and it might completely be the wrong way to go. So one of the thoughts I have is that eventually I might just have to replace these discs with either smooth or some rough surface. So it might just be a friction joint where I move in a position and then tighten this down and clamp it. A lot of machinist tools are done this way, and I was trying to avoid it because I thought having to click was going to be cool. Might still get there, but we'll see. I'm keeping that in the back of my mind because that may be the way we wind up going, because in the real world, things rarely turn out the way you expect.
Here you can see the rendering of the spherical joint in SolidWorks. The mere nature of a ball joint itself gives it quite a bit of articulation. And on to the 3D printing. This ball joint is essentially a friction joint. The pressure exerted on the sphere will result in a static friction force which will resist torque on the sphere to inhibit movement. Pressure is defined as force divided by area. As a function of torque, the larger the sphere diameter, the larger resistance torque there will be. Currently, the diameter of the ball is 2 inches. And I must admit, I got a little carried away. I drew the entire arm and I was thinking, hey, I could draw my own C-clamps and everything. But really, I think I will wind up connecting it to a bar clamp, just like Adam Savage wound up doing. I think having something prefab and made of metal might allow me to clamp to a lot more surfaces anyway. Here are the new 3D printed pieces fresh out of the machine. I'm just removing all the supports and deburring. It's a fun process. Here we can start talking about fits that I was talking about earlier. There is a hexagonal hole inside here that houses the nut, and I designed it to have a 1,000th press. So fits, the way they go, you can have a slip fit, which is anywhere from 1,000th oversize. A line-to-line fit is exactly the same size and can almost be a press fit, but a real press fit is 1,000th undersized. So if you want a press fit for a 1/4 inch hole, you would make the rod 0.251, 1,000th oversized with a 1/4 inch, so it would have some pressure when you push it in. The sphere itself didn't print too well. I think it just didn't have enough support as it was going through the machine. It still mates to everything just fine, so I'm not really that concerned about it. Everything fits pretty well. I also had some issues with mirroring the part in SolidWorks. I put a counterbore on one side to house these brass fittings and make them a press fit, but it also mirrored that counterbore on the other part, which was supposed to just be a flat stop for some socket head cap screws. So I'm lucky that the counterbore is smaller than the head, but I can still at least fit these brass fittings in where I intended them to be. And these were pretty well done. It fit really well. It was like a really snug fit, just enough to keep them in place. And they pushed in almost with my finger, but I had to get some pliers to push them in completely. Here's where you put the nut into place in the hexagonal hole. I must admit that one fit pretty well. It was a nice snug fit. Kept it in, won't ever fall out as far as I can tell. These discs are concave, so they mate with the outer diameter of the sphere. They'll have full surface contact to clamp down on the sphere whenever locking into place. And this is where I ran into some trouble. These plungers didn't want to fit. Apparently I planned for clearance in the larger diameter, but I didn't in the minor diameter. Not to mention the minor diameter was printed oblong in a way for some reason. You'll see in a minute whenever I get out the calipers finally and give up. One lesson is if you have to beat it into submission with the handle of a screwdriver, it's probably not a good fit. I thought maybe some sandpaper would help refine this a little. The fit was way too far off for me to actually get it that way. You can sand off 1/2,000th or 1,000th or so, but once you get in the 3 to 5 or more range, you might as well either machine it, start over, or find some mechanical way to whittle it down. I even thought needle files would help. These are actually quite helpful. These are really great for cleaning up small items. I got them in jewelry years ago, and they've come in handy many, many times. You can see here as I put the clamshells together with the plunger engaged that obviously the fits aren't great. I think the plunger is a little too high, so it wouldn't allow the clamshells to close completely. There's the beating into submission part again. I think finesse is something learned over time, but honestly, every now and then a little force does help. This time it did not. All right. Finally got the calipers out. You can see it's supposed to be a 5/8 diameter, but it's at 628. And if you rotate it, it shrank on one side, so it's oblong. The printer didn't print it at a perfectly round circle. So that's a problem right there too. 628 to 621. So when I measure the counterbore on this piece, you'll see that the max ID on this is probably 625, 626 maybe if you're pushing it. It's never gonna fit. You'll see on the other half of this clamshell that it's actually 621. And you'll see the depth of the counterbore is actually 0.219 versus a 1/4 inch. So I really have no choice but to reprint the plungers. And here are some nice new plungers ready to assemble. You can visually see that these were out of concentricity with the rest of it, and so I had to check in the model to see what was going on. Oh, look at that. The axis of rotation for the revolve cut wasn't snapped to the midpoint. Fixed it. Let's try again. With all the sizing, tolerance, stack up, and concentricity issues out of the way, this popped in quite nicely. And with all the bugs out of the way, it was finally time to assemble the ball joint. And guess what? My parts came in. Having a thumb screw versus a socket head cap screw to adjust this was great. These will definitely come in handy when I'm adjusting this whole stand.
this thing's looking pretty good. The ball and socket assembly did pretty well. Have lots of range of motion. And when I tighten this down, it locks down. It's not going anywhere, at least as far as the weight concern of a phone holding up here. So it's a beast already for just a simple phone hold, but I'm having fun. That's okay. I do not have any more of the correct 1/4-20 screws to attach the joints, and I'm also 3D printing the base to connect to the bar clamp, like so. So it'll clamp to the top of this bar clamp here. That's how it'll attach to the table or anywhere I really want to put it. So I figure in this building I can actually hang it from the rafters. I can clamp it anywhere that gives me a good shot over my tooling. It'll really make things quite versatile. So I look at this as it can hold lights, it can hold numerous things as long as the rigidity of it is good. So after I get it all together, there'll be some testing to see what it can hold, and there might be some adjustment of the discs. The whole name of the game of this assembly is modular. So I have this assembly with shorter, medium, long. Well, these are both two. I have this assembly with 2 shorts, 1 medium and 1 long piece. And I have more short pieces if I want to make it longer, or I have more bases that I can swap out and they can tag it on the end. And I can replace the discs. So if I want to build this thing like Legos, I can build whatever I want. I can add to it, make my own accessories over time. That's the main thought process of all this. So we'll proceed forward. I've already had problems with it seems to work. Filming off of it right now, and it seems to be doing pretty well. I did wind up having to sand the discs off and basically get rid of the teeth on the pieces, which you saw in the video. It's a sad thing that I started out this video talking about ratchet joints and really wanted to have that click and positioning system type thing, and I might still be able to accomplish it, but honestly this thing works a lot better with it just having the ability to move at any increment possible smoothly and then clamp it down where I need it to go. It gives me more infinite positions I can work in, and it makes it really easily positionable instead of being inhibited by the angular separation of the teeth. So this may be an ongoing project and an ongoing improvement. I'll keep working with it and adding to it. Like I said, it's modular, so I can keep adding new stuff and hopefully it turned into something great. Right now, I'm really excited about it. It's hanging from the ceiling. It looks awesome and kind of gnarly, but I like it a lot. I made it myself. That circles all the way back to the first of the video. So repeating the question, just because someone else has made it doesn't mean you shouldn't try. I think the answer is no. You can ask the question, is mine better than Adam Savage's? I don't really know. I think his is brilliant. I think I like mine too. And I hope maybe somebody out there thinks it's brilliant, but I don't know. Time will tell. I think it's really important to do things for yourself. In the very least, you learn how to do something for yourself and you develop some style. You develop some knowledge through the trial and error and the problem solving inherent in the maker process. So I think it's a very good thing to do things for yourself, add your own spin, and you never know. Like I said, you might actually contribute something to the world. Everybody has a unique voice and they should try to put it out there. My grandmother once tried to peddle my artistic wares by saying, "Do you like weird stuff?" And that's honestly what she thought about it, but she supported me, so it came out of love. It just depends on people's perception. There might be somebody out there that loves your work. There might be somebody out there that hates it, and that's okay. Honestly, this thing could be used for monitors, for phones. I could put lights on this thing. Like, I'm hanging it from the rafter right now, and I have the ability to move it around and change position, and I can give you some different angles, and it makes it interesting, and I might actually make this YouTube channel more interesting overall. So, if you like this video, thank you for staying with me. As I said last time, you have great patience, and I appreciate you watching the whole thing. If you really enjoyed this, I encourage you to subscribe. I'm grateful for everybody, and I have around 37 at the recording of this video, which is awesome. We built it up a little bit more. If you like this video, check out some of my woodworking videos, such as the ottoman tray or the drawer face failure. You might find something useful in there too. All right, thank you.